This is chapter 10, the quadratic function. This is the first exercise, exercise 10.1, graph of a quadratic function. Now the quadratic function has general form y equals ax squared plus bx plus c. Now this quadratic function, if we were to sketch it, you would get the shape of a parabola. We know that it's a parabola because the highest power of x is x squared. You can or cannot, you may or may not have an x term, and you may or may not have a constant term here. Now, when we look at our parabola, y equals ax squared plus bx plus c, we know that a, b, and c are just constants. Now, a can be positive or negative, and if a is positive, in other words, if a is greater than 0, and that might be like y equals 2x squared or y equals 4x squared or just y equals 1x squared, then the parabola is what we call concave up, so it's upwards facing. And if a parabola is concave up, then at the very bottom tip of the parabola we will have what's called the minimum value of the parabola. Now the minimum value is always the y value at this point. Okay? Now, looking again at the general form of a quadratic function, y equals ax squared plus bx plus c, a can also be negative, so you might have y equals negative 2x squared plus something or whatever, or y equals negative x squared, or y equals negative a half x squared. So if a is less than 0, then the parabola will be downwards facing, and we call that concave down. And if the parabola is concave down, then at the very top of the parabola we will have what's called the maximum value of the parabola. And the maximum value will be the maximum y value at this point. So you could come across and see what the maximum y value is there. Often you won't be able to read it, you'll have to do some substitution to find it out. So the way that we find the maximum and the minimum value of a parabola is to find where the axis of symmetry of the parabola is. So first thing is, the axis of symmetry, can always be found using the formula. Now the equation of the axis of symmetry of a quadratic function, which is y equals ax squared plus bx plus c, is given by this formula. X equals negative b over 2a. So you would do the negative of the value in front of the x and put it over 2 times the coefficient of the x squared. Now that's one way of finding the equation of the axis of symmetry. Now you would do this if you just want to find the equation of the axis of symmetry straight away, but another way of finding the axis of symmetry is to work out the x-intercepts, and the axis of symmetry is always halfway between the two x-intercepts. So let's say if this was -1 here and this was, say, 3, then the axis of symmetry would be here at x equals 1. Okay, so you would do the average of the x-intercepts and divide it by 2. That's another way you can find the equation of the axis of symmetry. Okay, now I'll do that in some of the examples, but you can just use the formula. Axis of symmetry is found by, the axis of symmetry is actually a straight line. It's an equation, so it will be x equals something with these parabolas. So it might be x equals 2 or x equals 1 or x equals -3. So the way it's found is using this formula, x equals minus b on 2a. Now once you've found the axis of symmetry, you can then go back and find the maximum or minimum value of the parabola. So once you've found the x value at the axis of symmetry, you then substitute that x value into your equation, and you'll be able to then work out the y value. So the minimum or maximum value of the parabola is function of negative b on 2a. In other words, it's negative b on 2a is actually x, the axis of symmetry, so it's the function of x, or remember function of x is same as y value, so it's the y value at the axis of symmetry. In other words, you just substitute the x value at the axis of symmetry into your quadratic function, and that will give you the minimum or maximum value of the function. Okay, now we're going to look at some examples. Okay, now here is our first question, to find the equation of the axis of symmetry and the minimum value of the parabola y equals x squared plus 3x plus 2. Now we can, this is actually exercise 10.1 question 3. Okay, now You can actually factorize this one if you want, but I will do that later. We're just going to use the axis of symmetry formula, okay? So the equation of the axis of symmetry, so I just write AOS is x equals negative b on 2a, which happens to be negative 3 because a is 1, b is 3, and c is positive 2. So it's negative 3 over 2 times 1, which happens to be negative 3 on 2, which is negative 1.5. So the equation of the axis of symmetry is negative 1.5. And the minimum value, we know that this is a concave up parabola. So without, see, I really don't have much detail here. All that I know is that the axis of symmetry is at negative 1.5. I also know that when x is 0, that y is 2, so I know that the y-intercept of my parabola is 2. I know that I've got an axis of symmetry here at negative 1.5. And I actually haven't worked out the x-intercepts here because I haven't factorized it, but I could do that, and I will do that in a minute just to show you. Now what we can do is, now I know it's concave up, so it's going to look like this. I can work out the minimum value of the parabola by substituting in x equals negative 1.5 or x equals negative 3 on 2. So the minimum value will be y equals negative 3 on 2. So I just substitute it into this equation here. So I get negative 3 on 2 squared. Make sure the negative 3 on 2 is in brackets, square. Sorry, I've just had to pause the video then and restart. So we've got negative 3 on 2 squared plus 3 times, again, negative 3 on 2 is the x value that we're substituting, and then plus 2. So we've just substituted x equals negative 3 on 2 into this equation up here, x squared plus 3x plus 2. And remembering we're squaring the negative, so it becomes positive, and 3 on 2 squared becomes 9 on 4. And then we get plus negative 9 on 2, so we get minus 9 on 2 plus 2. Now this is the same as doing 2 1/4 minus 4 1/2 plus 2. Now you can just do that on your calculator if you want, or you can do 2 1/4 plus 2 is 4 1/4, and taking away 4 1/2 you would get negative 1/4. So therefore the minimum value of the parabola will be negative 1/4, and so the vertex of the parabola is the xy value. It'll have an xy value, and it will be negative 1.5 or negative 3 on 2, and the y value at that point will be negative 1/4. So now I can draw the vertex of the parabola in here. So here is negative 1, negative 2. That's my axis of symmetry, x equals negative 1.5 up there, and my minimum value is negative 1/4, which is fairly, you know, it's fairly close to, it's fairly low down here. It's not that far down at all, okay? Now this isn't drawn very well to scale, okay? It's not drawn well at all. I shouldn't really indicate where the x and the where the x-intercepts are. Now if I want, I can try and factorize this. So I've got y equals x squared plus 3x plus 2. If I factorize that, I get x plus 2, x plus 1. And so therefore I can actually draw this a little bit better now. I shouldn't have probably done that before, but I can actually, when I put y equals to 0, so when I put this equal to 0, I work out that my x-intercepts are negative 2 and negative 1. Actually, this hasn't been drawn very well. I'm just going to do the whole thing all over again. So I'm going to say, right, this is my y-intercept up here. It's 2, because when x is 0, y is 2. My x-intercepts are negative 1 and negative 2. Okay, this might be negative 2 down here. My minimum value, I'm trying to draw it to scale, but probably not doing a very good job. This is my axis of symmetry at negative 1.5, and my minimum value here, I've got negative 1.5 for my vertex, negative 1/4. So this point here is negative 1.5, negative 1/4, and my minimum value of my parabola is negative 1/4. It's always the y value at the axis of symmetry. Okay, this is a minimum because it's a concave up parabola. Okay, so the minimum value is -1/4. The axis of symmetry is x equals -1.5. Because we could factorize it, we could easily see the x-intercepts, and they are -1 and -2. And also by substituting the y-intercept is found by substituting x equals 0. And we know that the y-intercept is 2, because if you substitute x equals 0 in here, you get 2. So they're the basics, the basic things that you can do when you're trying to draw a parabola. You should always be able to see the y-intercept straight away. You should always be able to work out the axis of symmetry and the minimum or maximum value. And if it's a parabola that can be factorized quite easily, you can work out your x-intercepts. Okay? All right, we're going to now look at exercise 10.1, question 6. Now, I think this one can't be factorized. Sorry about that. Okay, so we've got, with this question, we have to find the equation of the axis of symmetry and the maximum value of this parabola. We can see that this parabola is concave down, so it'll look concave down, and so it will have a maximum value on top. Okay, so let's look for the axis of symmetry. So the equation for the axis of symmetry is x equals -b on 2a. Now our b is 2, so it's -2 over 2 times. Now my a is -1 because -1 is the coefficient of the x squared. So my axis of symmetry is -2 on -2, which happens to be 1. So x equals 1 is the equation of my axis of symmetry. We know that the parabola is concave down, and we know that it has a y-intercept of -7. So I'm going to write that down as well, that the y-intercept is -7, because if I substitute in x is 0 here, I get -0 plus 0, which is just 0, minus 7, so my y-intercept is -7. So I'm building up a bit of information about this parabola. My y-intercept is -7. My axis of symmetry, I'm just going to start sketching it now, is x equals 1. Now you can see, well, I'm pretty sure it doesn't go up higher, but I'm just guessing it's about there. I probably shouldn't have drawn it yet. I really don't know how high up this goes. It could go down here, it could go all the way up there. We'll just see what we get. I'm now going to work out the maximum value of this parabola, and hopefully it's negative something. So for the maximum value will occur, I'll find it by substituting x equals 1 into my equation, into y equals -x squared plus 2x minus 7. So be careful, it's -1 squared. I don't put it in brackets because I want the negative of whatever x is squared. I have to square the x first and then put a negative out the front. So it's -1 squared plus 2 times 1 minus 7. So it's -1 squared is 1 plus 2 times 1 is 2 minus 7, and I get -1 minus 7 is -8 plus 2, and I get -6. So I've actually drawn that up a little bit high, so I'll just bring it down a bit. This is not drawn to scale, okay? So as long as I don't put markings along here, I can just sketch it like this. And so my vertex, oopsie, I've written that out incorrectly. My vertex is 1, -6, so the vertex is 1, -6. Now, you can see that this parabola does not cut the x-axis up here. So if I tried to put that equal to 0 up here and solve it, I would get no solutions, okay? I'd also never be able to factorize this as well, which is why I've got no solutions here as well. Okay, so my vertex is 1, -6, and my maximum value is y equals -6, okay? So we'll go to another example now. Okay, now this is exercise 10.1, question 9, and it's similar to previous questions. It says find the minimum value of this function, y equals x squared plus x plus 4, and how many solutions does the equation x squared plus x plus 4 equals 0 have? So what we'll do, we'll first work out what the axis of symmetry is, and the formula for that is x equals -b over 2a. So I'll just work that out. Now looking at this we've got a is 1, b is 1, and c is 4. So we've got negative 1 over 2 times 1. So the axis of symmetry is x equals negative a half. And the minimum value will occur. To find the minimum value, we will substitute x equals negative a half into y equals x squared plus x plus 4. Now it will be a minimum value because this is a concave up parabola, because the value in front of the x squared is positive, so it's concave up. So to find the minimum value, substitute x equals negative a half into your equation, and we will get that y equals negative a half gets squared, because the whole of the x squared gets squared, plus negative a half plus 4. So negative a half squared, we're squaring the negative, so it'll become a positive, so we get a quarter, plus negative a half means minus a half plus 4. And so I've got 4 1/4 minus a half, which is 3 3/4. So therefore, if I do a quick sketch of this parabola, I can see already that my x-intercept, when I put, sorry, my y-intercept is 4. So I'm just going to write that down as well. Y-intercept is 4, because when you substitute x equals 0, you find it by substituting x equals 0. If you substitute x equals 0, you get y is 4. So I know that my y-intercept is 4. I know that my axis of symmetry is x equals negative a half. And I know that the minimum value of my parabola is 3 3/4. Now, if it's a concave up parabola, and the minimum value, if I say that's 0 to, let's say this is about 3 3/4, it's going to look like this. Because it's got to be concave up. The axis of symmetry is on the line x equals negative a half, and the minimum value is 3 3/4. So the vertex, sorry, that was just to stop in the tape there. So I think I was saying, so the vertex is negative a half, 3 3/4, the y-intercept, which is below the y-intercept, because the y-intercept has a value of 4, and the minimum value is 3 3/4, so it's below that vertex. So please sketch that accurately. Okay. Now, when it says how many solutions does the equation have, notice we're replacing the y with a 0 here, and y equals 0 anywhere along the x-axis. So this parabola actually does not